What are your responsibilities at UGA?
I wear, well, maybe this is a better way to answer it. I'll tell you the responsibility. There are three or four.
Oh.
I teach,
Mm-hmm.
I do research,
Mm-hmm.
I also do some administration. Uh, I'm 50% the director of Curo program.
Mm-hmm.
I run the Center for Undergrad Research Opportunities. So that's 50% of my, I'm the associate director, not
Right.
director. So that's three. Now there is a fourth. I do a little bit of what I call outreach work.
Right.
Like if I develop a technology,
Mm-hmm.
I take that technology to the people. I don't have any official assignment for that. Like, you know how they when you say responsibility, I'm paid, and what I'm paid is divided up in those. I'm not paid for doing it,
Right.
but I do it anyway.
What kind of research do you conduct?
Again, that's a difficult question. I research in about three areas.
Mm-hmm.
I do research that is related to drug discovery, like those guys I've been talking to here.
Mm-hmm.
My lab grows cells in certain scaffolds. We use these, we call them constructs.
Mm-hmm.
We use these constructs in preclinical drug discovery. We're trying to produce something that mimics the body. We make a micro tissue,
Mm-hmm.
and this micro tissue we try to use in what we call high throughput drug screening.
Mm-hmm.
That's been my signature work here, but I'm less known for that.
Right.
What I'm most known for is this work developing technology for people at what we call at the base of the pyramid. These are people who are rather poor,
Mm-hmm.
and everybody neglects making technology for them. And we've done this, and I do it with undergrad students. So that's research. It's a little bit design, applied research, and trying to carry that work in the field, maybe creating companies that can sell these products and so on and so forth, or getting other companies once we've developed it to
Mm-hmm.
take it over and market it to these people. So those are two distinct areas of research. But I've got a third area of research that is kind of like a pedagogical or teaching.
Mm-hmm.
The students I engage in these kind of base of the pyramid
Mm-hmm.
product development and research, I study them. I study them with a question: in what way does engaging them in these kinds of experiments affect them in terms of their choices down the road, career-wise
Mm-hmm.
or civic engagement?
Mm-hmm.
It's a question that I'm interested in. Not only, first of all, I've got to be interested in short term. Once we go, we come back,
Mm-hmm.
have they changed? And then I want to look 5 years down the road,
Mm-hmm.
in what way are they different from their colleagues who did not engage in a global type of work.
I found how you encourage your students to build the milk coolers.
Yes.
Could you explain that a little bit more?
That's our signature product.
Right.
It's the most famous product. The way that has worked, I developed a structure here. My original goal was, can I make them add global dimension to what they do? I want to produce students who are going to be very competitive
Mm-hmm.
in the 21st century, which
Mm-hmm.
we already are in. So I said, well, let me take the course, it's the final capstone course, bring in a project, a problem from a developing country. They work on it, and I take them there during spring break,
Mm-hmm.
1 week or 2,
Mm-hmm.
so they have the context. So that's where it started. And then when we began to make solutions,
Mm-hmm.
it was apparent there is no point making a paper solution
Right.
without ever implementing it.
Mm-hmm.
So then I added a component. In the summer, I hire a student, and he makes the product.
Mm-hmm.
Once we made it, we said, well, why don't we test it in the field?
Right.
Then I developed another program where I take students, they spend 8 weeks in the field. Either they are testing it in the field, or they are researching to make it perfect.
Right.
And once we did that, it's well, somebody needs to sell this thing.
Mm-hmm.
So, well, we either need to go get a company that is interested, or we set up a company ourselves.
Mm-hmm.
So, in some products, we've gotten companies interested. In the milk cooler, we set up a company, a sort of, they call it hybrid.
Right.
The hybrid is you have a non-profit and a for-profit together, operating together to make the product work. So that's how the milk cooler has evolved. The milk cooler demand is like this. Small-scale farmers who live far from cooling centers lose their evening milk because they don't have an ability to cool it.
Mm-hmm.
So what we've done is say, well, can you make something that doesn't use electricity that can cool the milk so the milk will be fresh the next day?
Mm-hmm.
And that's what we developed. It works off a principle of evaporative cooling. The simplest way to explain it, it would be like this. You know, when you go to a swimming pool on a windy day
Mm-hmm.
and you're wet
Mm-hmm.
and you come out and you stand outside, you're going to feel cold.
Right.
The reason you're feeling cold, you've got evaporation of the moisture on your surface
Mm-hmm.
that's sucking the heat out of you. This is a little bit the same way.
Mm-hmm.
But in this case, the engineering is hard
Mm-hmm.
to be able to cool something from 30 degrees all the way to 4 degrees in about 4 hours, which is required.
Mm-hmm.
So we have kind of tweaked the process, created a vacuum, and put all this together so that the product works. The product works. It's really important. The people I'm interested in are really poor.
Mm-hmm.
They don't have electricity.
Right.
And a lot of engineering things require energy. So we have to figure out how they're going to get the energy.
Mm-hmm.
In this particular case, it's really cool. Cool this way. They produce milk, so they have cows.
Mm-hmm.
The cow's poo
Mm-hmm.
can be fermented
Right.
in a digester
Mm-hmm.
to produce methane that we can use as energy. So the cycle is complete. Their cows produce the waste.
Mm-hmm.
The waste produce the energy that cools the milk from the cow, and the products of the fermentation process can be used for fertilizer. They can go and fertilize the grass that the cows will eat.
So it is really like a cycle.
Yeah, but there is something more cool about it.
Okay.
In these communities where they don't have milk cooling, they pile up the cow dung
Mm-hmm.
or the cow poo. And when you pile it up, it ferments and produces methane that goes into the air. You know, methane is not a good gas to put in the air because it's a greenhouse gas.
Right.
Now, if we tap it by preventing them to make the pile,
Mm-hmm.
they ferment it, we produce methane,
Mm-hmm.
we burn it
Mm-hmm.
in our product. So we break it down to water and carbon dioxide,
Mm-hmm.
and we release carbon dioxide in terms of methane. The difference between methane and carbon dioxide is this. Methane is 21 times more potent as a greenhouse gas than carbon dioxide.
Mm-hmm.
So we're killing two birds with one stone.
Right.
Farmer getting richer,
Mm-hmm.
we're also helping the environment.
Wow.
So that's why we like.
What are some other technologies that you've worked on that has helped?
We've got a total of 4 technologies. The first one, the milk was the one we started with, but it's been the most difficult. But also it has the largest market.
Right.
Its demand is all over the world.
Mm-hmm.
You know. The second was a solar-powered hatcheries, small, to put a pair together, about 200 eggs, for people in the Sahel. Sahel, those are the countries just below the Sahara.
Right.
Those countries like in Niger, Ghana, Nigeria, Senegal, Burkina Faso. In those countries, they really like this bird called guinea fowl.
Mm-hmm.
Guinea fowls are very unique. When you put them in captivity, they don't sit on the eggs. So what they're doing to produce these, to fool a hen,
Mm-hmm.
a standard hen, put guinea fowl eggs under it, but each hen may hatch 5 or 6. So we needed an incubator to increase productivity so that people can produce eggs. We put them in here. So we developed a product. There is a company in California that's taken on this product, and they are trying to market it in Haiti. In Burkina Faso, it's been very slow to enter the market, but we've tested the product, works very well, ready to go. The second product was a product related to milk, making ghee. So we we mechanized it.
Right.
The way they make it in many African countries, you've got a small pot. Like you see that thing on the shelf. That is the kind of thing in which they put the milk and shake it.
Right.
They make a very small volume. So what I wanted to say, can we mechanize that shaking and make it larger 30, 40 times? We made a product, and our product works. It hasn't been commercialized. Essentially, we haven't just created the business to do it, or somebody hasn't picked it up, but it works. The third product that is still really under development is a nut cracker. In Morocco, western Morocco, there is this tree called the agan. The agan tree is found in the Sahel, really. It's very good for stopping deforestation, but it produces this nut that produces this oil. The oil, I don't have it here, it's in the lab. The oil is very high demand. It has a lot of antioxidants. It's got great organoleptic properties, very nice to cook with, very high demand. But the women who crack these nuts, they are the hardest nut in the world to crack. I've measured their strength. They crack them between stones. They have a stone underneath, and they put the nut, and they hit. They hit their fingers. Productivity is very low. So we needed to make a mechanical device that can increase the speed. And we made one. We actually were going to get a patent on it, but it wasn't a good idea. But one of the mechanisms that we've got a mechanism in there actually that we'll patent that synchronizes the pulling with the rotation so that new nuts come in, you crack them, you bring back new nuts come in. The synchrony there is a very ingenious thing. But the mechanism sticks after you've done it, so we need to do development work. But we're putting it on a shelf waiting so we can commercialize the milk cooler.